Yeah, welcome to Easy Mathematics and a new video, the parabolic sieve for primes. And the setup is following. We consider the normal parabola y equals x squared, and then we take care of integer coordinates lying on the parabola. Yeah, for example, x value n, then the y coordinate is n squared, and also if here is the x value is m, then the point m squared is on the parabola, and n, m are integers. Okay, and then what we do is we connect all points from the right to the left. Yeah, so basically this connection we will not need, so we connect all the points from left to right. So for example, from 1 to 1, from 1 here to 2 there, if he 2 4 squared, so from, for example, 1 to here, then maybe from also here, then 3 and 9 squared, 3 and 3 squared, so maybe from 1 to 9, so something like something like that, and so on and so forth. Okay, I have no idea if the relation, if the what is the name? If the scaling here is okay. Yeah, and so we have integer coordinates on the parabola, and we connect them via lines. Okay, we can make a first observation that the intersection points, so if we have that the intersection points are also integers. And the question is, what kind of integers do we get here if we connect them? Yeah, and which one do we not get? And if we do this carefully, it seems that we do not cross the I can tell you that it seems like we do not cross the 2, not the 3, not the 5, not the 7, not the 11. So it seems like all the primes will not be part of the intersection points. So please pause the video and make a proper picture of the situation. Here I have, of course, some problems with the scaling, but if you do it on a nice paper, you will see that we do not cross the primes. And the question is this also like a sieve for primes? Yeah, and we will calculate it if this is the case or not. And the result is that we only cross composite numbers, and yeah, therefore we will prove it. And so we are given 2 points P and Q on the parabola, and P and Q have integer coordinates, let's say n squared and m squared, and m are integers. Okay, and our goal is to show that the line through P and Q intersects the y-axis how can we write it? Intersects the y-axis, so all xy with x0, and what we get is all the points on the y-axis and of the form so what we get is all the composite numbers. This is our goal to show, and it's a straightforward calculation, and therefore, and of course, what we assume is if we take, for example, n here and m also here, then the intersection is on the negative y-axis, but we will see up to a sign it doesn't matter, so we will not take care of any signs for n and m, okay? So we will see. Okay, so let's calculate the line through P and Q. This is y equals yp minus yq over xp minus xq, x minus xq plus yq. So yp is n squared minus yq is m squared over n minus m times x minus xq is m and yq is m squared. Here we have a difference of squares, so this is n minus m n plus m all over n minus m times x minus m plus m squared. Here n minus m, it cancels out and we get n plus m x minus n times m minus m squared plus m squared. So these two cancels out and we are left with n plus m x minus n times m, and this part is what we are interested in. So if we plug in x equals 0, we get this part, and we see if we take m positive and n, for example, negative or vice versa, this product becomes positive, so we are on the positive y-axis, and we see here, because n and m are integers, we only get points on the y-axis on the m values which are composite. So therefore no primes on y-axis is an intersection point. And therefore we have like a parabolic sieve for prime numbers. Isn't that beautiful? Yeah, and that's all for this video. Hope you enjoyed it. See you next time and bye bye.